output from one machine, such as a relay output signal on a pump control circuit, to a 24-volt DC input on another piece of equipment, such as a PLC. Which of these is an advantage of an SSR over a mechanical relay? Describe how to select a solid-state relay. SSRs are rated by several factors that are used to select them for an application or replace an existing SSR. These factors, which are typically available on data sheets provided by the manufacturer, include mounting requirements, output voltage, output current, input voltage, and input current. SSRs are typically grouped into families or product lines according to the mounting style. Typical mounting styles are DIN mount, panel mount, socket mount, and printed circuit board mount. SSR models are often classified according to the rated load voltage. This is listed on the data sheets as nominal line voltage. The data sheets define a minimum and maximum line voltage that the relay can switch safely. The SSR may be damaged if it is connected to line voltages above the maximum rating, but may not be able to drive the output correctly if the minimum line voltage requirement is not met. SSR data sheets define minimum and maximum load currents that the relay can switch safely. The SSR may be damaged if it carries a load current above the maximum value, but may not be able to drive the output if the load current is below the minimum value. SSR data sheets define a minimum and maximum voltage, sometimes listed as the control voltage or pickup voltage, which can safely be applied to the relay input. Using a control voltage above the maximum rating may damage the relay, while a control voltage below the minimum may not be large enough to energize the input. Solid-state relay data sheets define a minimum current, known as the turn-on current, to be connected to the input. Connected input currents below the turn-on current may not be large enough to energize the input. An existing solid-state relay used to energize a small scrap conveyor motor has failed. The failed relay has these characteristics: 24 volts DC control voltage, 240 volts AC line voltage, and 2 amps load current. Which solid-state relay best meets the requirements of the application? You should have found that replacement 5 should be used. Replacement 5 is the only one that has a line voltage range high enough to operate with 240 volts AC. It also has an adequate load current and control voltage rating. An existing solid-state relay used in an interlock circuit between a hydraulic pump system and a cooling tower has failed. The failed relay has these characteristics: 24 volts DC control voltage, 230 volts AC line voltage, and 20 milliamps load current. Which solid-state relay best meets the requirements of the application? You should have found that replacement 2 should be used. All of the replacements have the correct control voltage range. However, only replacement 2 has a line voltage that can use 230 volts AC. An existing solid-state relay in an interlock circuit between a robot and a conveyor has failed. The failed relay has these characteristics: 24 volts DC control voltage, 120 volts AC line voltage, and 10 milliamps load current. Which solid-state relay best meets the requirements of the application? You should have found that replacement 1 should be used. There are 2 replacement SSRs available with the correct line voltage range, replacement 1 and 4. The control voltage of 24 volts is available for replacements 1 and 4. However, the load current range of replacement 4, 50 milliamps to 3 amps, is too high. Replacement 1 is the only one that meets all 3 requirements. Select a solid-state relay given an application. In this procedure, you will determine the best replacement SSR for a failed SSR using information from SSR data sheets. Click on the pencil and paper to view the step-by-step instructions for performing this procedure. Describe how to test a solid-state relay. Normally, when a control voltage is applied to an SSR's input, its output will turn on, allowing current to flow to the load. If an SSR has failed, it will most likely not turn on its output when it receives an input. SSR testing involves working on live circuits and requires caution by the technician. An SSR is tested using 3 steps. Step 1. Measure the line voltage. A DMM is used to measure the line voltage supplied to the output side of the SSR. A low or missing line voltage indicates that the problem is not in the SSR, but some other component. Possible sources include failed power supply, blown fuse, tripped circuit breaker, and ground fault. Step 2. Measure the control voltage. A DMM is used to measure the control voltage at the SSR's input side before the control voltage is applied to the input. A low or missing control voltage may indicate a failed power supply, blown fuse, tripped circuit breaker, or a ground fault. Step 3. Apply the control voltage input and measure the output voltage. With the control voltage applied to the SSR's input, the last check to make is to measure the voltage at the SSR's output terminals. If it is a high voltage, the SSR is faulty because output terminals are still acting like an open switch. A voltage near 0 volts should be measured across these terminals if it is functioning properly. If the measurement is normal and the load is not operating, the problem may be with the wiring to the load or the load itself.